Hi, my name's Wes Dobry, and I'm a principal engineer at Eclipsium. Today, I wanted to talk to you about how to protect beyond the operating system. As I call it, it's really the hardware and firmware integrity journey. And what I often find is that the most ignored components of zero trust and trusted supply chain are really focused on hardware and firmware integrity. And I want to talk through a little bit about why attackers are targeting these areas outside the operating system, and ultimately how to ensure that your IT hardware doesn't have any hidden threats, and how you can integrate this into your existing security controls. So, when I talk to organizations, as you can probably imagine, they have a lot of computer equipment. So, things like your laptops, your desktops, and your server infrastructure. But these components are ultimately made up of a lot of chips, boards, different components therein. Now, all of these components, of course, are made at a whole bunch of factories around the world by third parties. These third parties have third parties, and even after you buy the equipment, it's still changed hands. And that means things like your VARs, your strategic integrators, people that you buy from may not even be the manufacturer of it. And the manufacturers may be buying from third parties as well. So ultimately, this begs the question of how are we expected to trust that the hardware is safe and that the firmware running on this hardware is safe? Because ultimately, most organizations do not have the appropriate tools to know if these third parties have their best interests in mind. This also means that your third parties may be running things like insecure code within their firmware. Maybe they're bringing in third party repositories or open source software that may have vulnerabilities built into them, or maybe they could be having nefarious folks within their organizations that are actually targeting your organization. And you can end up adding risk by just trusting that these devices are good and safe. Now, you can have scenarios where bad actors can actually compromise one of your third-party suppliers. And as an organization, a lot of us just simply trust that. We figure, hey, if we bought this from somebody that we trust, we're going to add it to the environment, and it's likely going to be just fine. This is a low-risk opportunity for most customers, and so why should I do anything about it? But this also comes into play that most organizations are not inspecting their hardware supply chain, and they're definitely not doing things like validating the firmware that are on these devices. So this also means, and in conjunction with, a lot of organizations are not maintaining a firmware update process, and so they actually have a ton of unknown vulnerabilities and risks that don't come up in your risk management programs and your vulnerability management programs and your patch management programs. And you can end up now in a scenario where you have a ton of unknown risk that you haven't looked at, haven't seen, and aren't aware of. So that's really where Eclipsium can come in, is that we help organizations like yours to enforce zero device trust by really twofolds. First is assessing devices coming into the organization, validating that that hardware is good, known, and trusted and comes from a trusted source. And it also helps on devices that you have within your organization to assess what's on them, what they're running, and help you build out a patch management and device firmware management structure so that these devices can maintain a good, known, trusted firmware and hardware methodology. So I like to simplify this by saying that Eclipsium is simply firmware visibility, firmware integrity, and firmware security. And what I mean by that is on the visibility side is understanding what assets you have inside your organization, what components they're made of, and what the firmware is that are on them. The integrity side of things is taking information about that hardware and firmware and ensuring that it's actually what came from the manufacturer. So whether that's validating that the hardware was exactly as it was built in the factory, or is that actually validating things like the firmware source itself, making sure that that BIOS or that PCI option ROM is exactly what shipped from the manufacturer. And then on the security side, it's things like vulnerability and risk and misconfigurations. Understanding what vulnerabilities the firmware that you have running in your environment contain, and ultimately what you can do about remediating that. So I always like to simplify this and take this even a step back. That when I talk to most enterprises, you find out that firmware has typically always been pretty synonymous with the term BIOS or system firmware or some simplistic term that signifies that there's one piece of code running everything on a machine. But what's happened these days is machines have gotten much more complex over the last few years, and you now have scenarios where there are a lot of pieces of code running on a lot of different components in different arenas on that machine. So you can now have things like updatable microcode within the CPU that can have vulnerabilities in it, allowing side channel attacks. You can have things like baseboard management controllers, which are running an entirely unpatched version of Linux on them that you have no visibility to within your organization. Or you can have things like network cards or even peripheral devices that can have malicious code on them that were put into your environment by a nefarious individual. And the reason why this is becoming more and more important is that if you look at CISA's known exploited vulnerability database, or CISA being the Cybersecurity Infrastructure Security Agency, over the last few years, we've seen a rapid increase in the number of vulnerabilities that are being actively exploited that fall into the firmware category. And so this means that attackers are starting to focus on firmware itself and the entire arena of firmware and supply chain vulnerabilities. And that's ultimately because for most organizations, firmware is the largest blind spot. We're not looking at it. We aren't developing mature programs to make sure that things are actually up to date and running as we expect it. And ultimately, it's an area where they see a lot of opportunity. Now, bad actors typically will target firmware for a couple different reasons. The first being to avoid detection. If you're in firmware, it means that a lot of OS tools won't even pay any attention to you. So you can go undetected for a very long period of time. The second is around persistence. If I'm in the outside of the operating system, then if that operating system on the device is reloaded, then I can reimplant into it. So even if the hard drive is changed or the device is completely rebuilt, I can maintain persistence on that device. And then the last one is ultimately around destruction. So physical device destruction and data destruction. If I'm running at the hardware level within firmware, then I basically have keys to the kingdom to do anything on that device. So what does this ultimately mean? It means that a lot of organizations focus on these areas in green. They focus on the host operating system. They focus on the applications and the hypervisors and the virtual machines. And ultimately, that's where we have a very mature stack of tools like your EDRs, your XDRs, your network vulnerability scanners, your endpoint protection products. And you have a lot of these different tools within your portfolio to ensure that your environment is as safe and secure as possible. But we often find that organizations spend zero time focusing on the areas that I've highlighted here in red. And they don't look at things like what bootloaders do they have running in their environment? Are they properly doing things like secure boot? Is your TPM provisioned correctly? Those types of areas. And that's ultimately exactly where Eclipsium focuses, is that we want to be supplemental to your existing security stack to fill in these gaps under the covers about how you're getting your equipment, what the firmware on that equipment looks like, and ultimately how secure is it, and if there's any risk imposed to your organization. So I simplify this again and say we're focused on firmware security, and that's focused on areas like your endpoint PCs, so your laptops, your desktops, and your workstations. Your rack-mounted bare metal servers, so areas where you're actually running on hardware. So that would be things like your HPE servers, your Supermicro, your Intel servers, your Dell servers, and the like. And then also in your networking equipment, where firmware takes a slightly different definition, where it's the entire running operating system on that, because again, it's not really something that organizations can modify directly. So have us take a look at that and verify the integrity of things like your Cisco network switch to ensure that there isn't anything planted in the running OS. And the way that this actually functions is that Eclipsium sets up a single dedicated cloud tenant per customer, and that's where all of the real magic happens. This tenant is fed with our intelligence feeds, which are things like how we actually analyze firmware, new vulnerabilities, our known firmware database or a known good database for when we're checking integrity of firmware, and ultimately all the intelligence that Eclipsium provides around firmware, supply chain, and manufacturing. And ultimately, you take your devices, so your endpoints and servers, and install a small piece of software on them. So this would be the Eclipsium sensor. It then collects the firmwares and metadata and identifying information about those devices, compresses, encrypts it, and sends it up to our analytics service for analysis. At that point, when we receive it, we effectively do automated reverse engineering and analysis of all of that firmware. And we'll look at it for risk, vulnerability, and threats within it. So that way, if there is a bad actor in the environment, or if there are any unknown vulnerabilities, we'll actually detect those and make sure that you're aware of them. These devices can also be used for doing remote firmware assessments on devices that can't have a piece of software put on them. So something like a network switch, for instance, where we can discover the device via standard network discovery protocols and then switch over to things like management interfaces like SSH and APIs to actually do an inspection of that device and validate its integrity. All of this information comes into where we can then display it on our console, so providing you a web interface so that you can see the information around your environment, and also through our RESTful API so you can integrate us with other systems within your organization. We also output data via syslog and webhooks so that you can integrate us with your SIM and SOAR products so that again you can have automated response when we have things like identification of a vulnerability, identification of a threat, or new devices coming into your organization that are discovered. And then on top of that, of course, we integrate with third parties for single sign-on purposes. Next, I'm going to actually show you a little bit of our web UI and what kind of data we actually collect. So we're now looking at the Eclipsium Management Console, and I always like to describe this in 3 sections. The devices section here falls into that visibility that I was talking about earlier. Understanding what devices are in your environment, what type of devices they are, and ultimately what components are they comprised of. The risk section here is exactly what it sounds like, risk to your organization. And that's again things like vulnerabilities within the firmware itself, devices that are out of date on firmware, and taking information and intelligence that we have about the environment and mapping that to NIST 800 controls. So showing you exactly how you stack up against specific guidelines and controls and providing you recommendations on how to improve that security posture. The integrity side is the threat side of things. So firmware implants, meaning known malicious code that we've identified through indicators of attack and indicators of compromise within your organization. Integrity failures being pieces of firmware that are unknown to us. So something to take another look at and understand why it's different from what we expect it to be. Firmware changes so that you can understand exactly what's happening within your environment at any time from a firmware perspective. And then baseline deviations being devices that have anomalous configurations or anomalous changes on them that you might want to look into additionally so that you can understand the risk to your organization. So if we jump in first up here to this report on devices with high risk, this takes me into a list of vulnerabilities that are found within an organization. So in this case, you see a nice long list of vulnerabilities that vary from things like baseboard management controller vulnerabilities to device firmware vulnerabilities and similar. So if we go into one of these, we'll take this pants down vulnerability here. What we do at Eclipsium is we wish to go and provide you details about what the vulnerability is so that your teams can research it. Of course, recommendations for each vulnerability about how to increase your security posture on it, and then third-party referential information. I'm a big fan of security organizations or security products, not taking an approach to tell you that something's bad, but giving you the information so that you can ascertain that risk yourself. And then you'll also see over here on the right where we show you what the severity of that vulnerability is, if there's publicly available exploits, and if we know it's exploited in the wild. Within each vulnerability, we also show you information and other devices that may have that vulnerability contained in it for your reporting purposes. And now if we go back to the dashboard and we'll jump over here to the integrity side of things, where we'll jump into this list of 19 devices that have an implant detected, and we'll take a look at one of these devices. So when I jump into this device report here, I can of course gather a whole bunch of information about individual devices. We'll go ahead and jump into this one desktop here. And first thing that you'll see is that we collect some generic metadata about the device. The make and model of it, who's logged in, some IP addresses, operating system information. You'll also see that we gather data about how the TPM is configured, if the endorsement key is done correctly, and give you a validation on that so that you can trust the root of trust on that device. But as we scroll down, you'll see here this is where things start to get a little interesting on what Eclipsium actually does. You'll see all the individual components of firmware that we're able to extract off the device, and we present it to you in a simple to understand red, yellow, green format. Green being low risk to the organization, yellow being, something that you might want to take a look at proactively, and then red being something that you need to drop everything and take a look at immediately. In each one of these categories, you'll see that we have 4 different components underneath of here, where we look at them from an integrity perspective, a change perspective, a risk perspective, and of course, is it up to date? And that way we can then roll up the status per device and to the entire organization about things like vulnerabilities contained on that individual device. Is that device up to date? What updates are available for it? And then also on the integrity side of things around if we find something like a firmware threat or a known piece of malicious material on that device, as well as our analysis of the firmware binaries extracted from it. So in this case, you can actually see that we have found a UEFI SMM backdoor. We provide recommendations about what you should do for that device, and then also allow you to dive into why we detected that threat. On the vulnerability side of things, all of these known vulnerabilities that we've reported are drill down. So if you don't know what something like a platypus vulnerability or a cache out vulnerability is, you can simply click on it and get the information about what that is and what you should do about it. On the firmware update side of things, we can, of course, you see here that I have an update button where I can simply select and then take this device from version 133 to version 129 of the firmware directly from this UI. If I wanted more details about this update, I can of course select See Details here, where it then takes me into information about the firmware updates available for this device, where I can find out things like the specific CVEs updated within it, as well as all of the change logs between the version that I'm on to the version that I'm going to. You'll also see here that I have a download button where I can download directly from Dell's website, or an install button, which again allows me to schedule and push this install to this endpoint itself. All of this comes together to provide your organization the capability to understand what devices you have, what risk they provide to your organization, and ultimately, are there any threats or things that you need to kick off an incident response process on so that you have a full understanding of what your devices look like from a hardware perspective and from a firmware perspective. So I hope that was educational, providing you some insight into how things can happen below the operating system and how Eclipsium can help. With that said, I'm Wes Dobry. Again, I'm a principal engineer at Eclipsium. I can always be reached via either LinkedIn or email. My email address is wes.dobry, D-O-B-R-Y, at eclipsium.com. Thank you for the time today, and again, I hope this was informative to you.